right, so determine the KD and Bmax for myoglobin, real myoglobin, and then you've got this mutant myoglobin. And the mutant myoglobin has the histidine 64 replaced with glutamine. Now you guys know, right, why histidine 64, that's your distal histidine, is important for binding of oxygen, right? Think about it. It's extending something to your oxygen, and it's stabilizing the binding of the oxygen to the heme. Can glutamine do the same thing? Well, all right, you think about that. And anyway, you have some data here to kind of guide you. So the myoglobin protein is present at 2 micromolar concentration. So you are given our total. So that's going to make your life a little easier, right? Because it's telling you how much of the receptor is present in the system. And you know biochemically that myoglobin has 1 binding site for oxygen. It's giving you lambda max for oxymyoglobin, which is 417, an extinction coefficient of 128,000 per molar per centimeter. For the sake of this exercise, you can assume that deoxymyoglobin excuse me, has no appreciable absorption of light at this wavelength. You guys know from lab this week that's not exactly true, but pretend it is, right, for the sake of this homework exercise. So the first question you can answer based on what you know from lab, and given the assumptions above, right, which are here. And then you have to make some graphs. You're going to make 2 graphs of your data, a hyperbolic plot and a double reciprocal plot. Please paste screenshots of your graphs here. Right, pay attention to the labels and scales of axes and also include an appropriate legend. So please do that. I found it very difficult for whatever reason to download the Excel files out of Canvas, out of the grade book when I was doing the grading of the UV Phys lab. So please just put screenshots of your graphs right in this document, so it'll be way easier for me to just browse them. I'm looking to see the scale of the axis. Are you using appropriate labels? Are you using appropriate units? Are you providing a legend on your graphs? And then based on your graphs, you're going to determine KD, right, and Bmax, blah, blah, blah. From the double reciprocal plot, show all your calculations and watch your units. Here's your data, right? The data bears some review. So here's your data table, and you're going to be making your graphs based on this data. In this column here, you have your oxygen concentration. So this is your ligand concentration, and it's in terms of torr. So torr is a measure of pressure of a gas. There are equations you can use that if you look at the pressure of a gas above a liquid and the temperature of the liquid and the identity of the liquid, right, you can then determine the concentration of dissolved gas in that liquid. You don't have to do this. You can just use the pressure of the gas and take that to be the concentration of the gas. And that is fine. That is fine for this. In this column, changing the highlighter, in this column, right, you have the absorbance values. These are absorbance values for the receptor ligand complex concentration. So this is your receptor ligand complex concentration for the native or original unmutated wild type myoglobin. And you need to convert these absorbance values into concentration. So you're going to use this equation here. So the concentration of the receptor ligand complex is equal to the absorbance in this column divided by the extinction coefficient provided to you above. And that's going to give you your receptor ligand complex in terms of the units here, right, are going to be molarity. Your units will be molarity. So pay attention to your units. In the third column, let's get another color. In the third column, you have the absorbance values for your mutant myoglobin. So again, these are absorbance values. And you need to convert them once again to concentration values using the absorbance listed in this column with the extinction coefficient listed above. Then you're going to plot your data. Here are the plots. This is how you're going to plot your data. Put receptor ligand complex versus oxygen concentration. You have two plots that are going to go on this graph. One of them is mutant myoglobin. One of them is, excuse me, wild type myoglobin. And you're going to do a double reciprocal plot. And it is from this double reciprocal plot that you are going to be determining your KD and your Bmax. Okay. And that's it.